Okay, here is Unit 4, Lesson 6. This is going to be the last lesson of the unit. So this is it for the graphing stuff. We're going to I can identify parallel lines from characteristics of their equations. I can write the equation of a line when given information about a parallel line. We're going to do the same thing with perpendicular lines. Okay, so parallel and perpendicular, the difference on this. So parallel lines are lines that never intersect. Okay, so they, no matter what, no matter how long you graph them, if I kept graphing off the page and kept going, they'll never cross each other. So they are parallel to each other. Perpendicular, on the other hand, means that they meet at a 90-degree angle. So it's a perfect square. So these two lines meet at exactly a 90-degree angle. Okay, and then the fourth one here, I can write the equation of a line given information about a perpendicular line. So we're going to do everything parallel, perpendicular. Kind of the cool thing is just two things you got to memorize with these. So parallel lines have one characteristic and perpendicular have a different characteristic. So in the example here, we're supposed to graph both of the lines on the same coordinate plane. Now, we skipped standard formula or a standard form graphing, and this is in standard form. A few things that we kind of skipped over. Basically, I'll sum it up pretty quick here. If I want to graph this, get y by itself. Okay, so solve for y. We did a whole, or part of a unit, a whole day on solving for a variable in terms of other variables. So this guy right here, I need to get y by itself. So I would bring the 6x the other side, which means I would subtract 6x. And now that's on the right side. And then divide everything by 8 to get y by itself. So this would equal, okay, it would equal y equals, and it'd be 2. Actually, let me put this first. I'll put the negative 3/4. If I reduce that, negative 3/4 x plus 2. Okay, if you look at these guys, what do they have in common? They have the same slope. Okay, so let's graph them and see what happens. This one has a y-intercept of 6. And from there, I'm going to go down 3, right 4, down 3, right 4 would be somewhere over here. Okay, so I'll grab my ruler and connect these guys. And then this other guy, it's going to cross at 2. And then from that point, go down 3, right 4, down 3, and I'm off the graph again, right 4. And I got something like this. And if you look at these guys, when I graph them, they never, ever, will ever touch. Okay? It's kind of like railroad tracks or the sides of a road. They don't get any closer together or further apart. They just go the exact same distance. So what do the two lines have in common? They have the same slope. Okay, what's the difference between the two lines? Well, they do have different y-intercepts. Okay, so they do have different y-intercepts, so different. So if I were to summarize using the last two questions, two lines are parallel if, they are parallel if same slopes but different y-intercepts. And that's important because if they had same slopes, same y-intercepts, they'd be the same line. So if they had the same y-intercept and the same slope, they are the same line. It's not two different lines. You can't say they're parallel because they're not different lines at all. It's the same line twice. So it has to be same slopes, different y-intercepts to be considered parallel. So what I'm looking for here is I want to solve this guy. I want to make sure that the m is the same, but the b is different. So again, here's one in standard form. Pretty easy to get in slope-intercept form. Just bring this guy over. So I'm going to subtract 2x. And now, so y equals negative 2x plus 3. Even though it's out of order, this is still the m. So are the m's the same? No. So this one, they're not parallel. They have different slopes. Okay, this guy here, same idea. I need to take the top equation. I need to solve for y. So bring the 5x over, subtract 5x, and then divide by negative 2. So if I divide everything by negative 2, this guy here, I'll write it down here, it'd be y equals, I like to write the x's first. So it would be negative 5 over negative 2, which would be 5 halves. It's positive. And then 8 divided by negative 2 would be negative 4. So I'm comparing the, because this equation and that equation are the same. So I'm comparing these two equations. Are they parallel? So it needs to be same slope, different y-intercept. Same slope, oops, same y-intercept. So they are not parallel because of the same y, or same line, same y-intercept. So those two are the same line. There's no difference between those two. And then this guy up here, same idea. I want to bring the 8x, so minus 8x. That's over there. Now divide everything by 6. So this would be y equals, I like to put the x first, so negative 4/3 x. That's a good sign. Okay, good sign because they're the same slope. Now 30 divided by 6 is a positive 5. Same slope, different y-intercept. Good, those are parallel. Okay, so they have the same slope, different y-intercept, so they are parallel. Okay, so write the equation of the line parallel to this. So let's say instead of giving you two equations, I'm going to give you one equation and a point. Okay, so say if I just do a quick graph of this guy, so here it's up 4, down 3, right 1, it's something like this. There's that line. And then I've got this equation that goes through 7, negative 2. So over 7, down 2 is somewhere here. So I want to find the equation of the line that goes through this point. Well, it's got to be parallel to it. It's going to look something like this. Okay? But remember, we just did this Monday or Tuesday, depending on when you did it. We have a slope and we have a point, and you're trying to find everything else. So the slope of, find the slope of the given line first. Well, the slope of the given line is negative 3. So then find the slope of the parallel line. So this line must have a slope of negative 3. And then I need to find the y-intercept using that point, this point right here. Same way we did last time. You got y equals mx plus b. That slope is negative 3. And then I'm going to plug in 7 and negative 2. Plug in the point that you know and use it to find b. So this would be a negative 21 plus b equals negative 2, so add 21, so b equals 19. So my equation here would be y equals the slope, negative 3x plus 19. Okay? Let's see here. I had that line when I printed. That line should have went, sorry, this line should have went with the previous page, and that's a little bit off, but I'll fix that before I upload it to the to Canvas. Write the equation of the line parallel to this, and it goes through that point. So let's just get y by itself first. So bring the 2x over. So negative 4y equals 11 minus 2x divided by negative 4. So y equals, I like to put this first. So negative 2 divided by negative would be 1/2 x, and then minus 11/4. And just leave that improper. You don't have to fix that. Okay. So the slope the slope of this line is a half. That means the slope of my line is a half. So y equals 1/2 x plus b. Plug in the x and the y that you know. So 6 is the x, 1 is the y. And I'm going to try to find my b. So this isn't the right b, but this is the right slope. This is the given line. This is the line I'm trying to find. Okay. So the half of 6 is 3. 3 plus b equals 1. So subtract 3. That means b equals negative 2. So it would be 1/2 x minus 2. Okay, again, pause this anytime. I'm going kind of fast because I do have 3 pages of notes on this one. They're just big and kind of spread out, but I'm going kind of fast. So if you have trouble, pause the video, go back, rewind it, or make a note of it and send me an email, and I'll explain it even in further detail. So graph the line of the equation parallel to this line, but it goes here. So this line, I'm trying to find this line right here that goes like that. It's parallel to this, but it goes through that point. Okay. Let's see. So the slope of this line, it looks like it goes because step 1 is find the slope. So this would be down 4, 1, 2, 3, 4, 5, 6 over 6. So the slope is negative 4, 6, which would be negative 2/3. And then this point is going to be 1, 2, 3, 4, 5, 6. So negative 6. 1, 2, 3, 4, 5, negative 5. So I've got a negative 2/3. Oops. Negative 2/3 slope. The coordinate I'm plugging in is negative 6, and I should get negative 5 as an output when I put negative 6 in. So negative 6 times negative 2/3. Let's see here. So I put this over 1, that'd be a 1 and a 2. So positive 4, because they were both negative, so it's a positive when you multiply. Subtract 4 from both sides. I got b equals negative 9. So that's my y-intercept. So y equals, my slope again was negative 2/3. My y-intercept is negative 9. Okay, so that's parallel. Now we're going to do perpendicular. Okay, so kind of switching gears here a little bit. Perpendicular lines, we said earlier, these are lines that meet at a 90-degree angle. Okay, so they make a perfect square corner when they meet each other. Okay, so I'm going to graph these two, and we're going to look at, are they perpendicular? So the first one crosses at negative 5, has a 2/3 slope, so up 2, right 3, up 2, right 3, down 2, left 3. Lost my ruler for a second. And then the other one crosses at positive 1, and it has a slope of negative 3/2, so down 3 over 2, down 3 over 2, down 3 over 2, which is somewhere in here, up 3 over 2. Let the ruler do the rest here. If you notice, 90-degree angle looks like a square right there, a corner of a square. So these lines are perpendicular. What makes them perpendicular are their slopes. To be perpendicular, this is important. So before, to be parallel, had to be the same slope or y-intercept. On this one, it's really just the slopes. These can't have the same. If they're perpendicular, they're not going to have the same y-intercept unless that same y-intercept is the y-axis. We don't even look at the y-intercept though. Okay, we look at just the slope itself. The slope is both opposite, because look, one's positive, one's negative. So positive 2/3, negative 3/2, positive, negative. So they're opposites. So they're opposite, and they're reciprocal. If you remember, reciprocal means flip it over. 2/3, flip it over, 3/2. Okay, so they're opposite and reciprocal. So examples of opposites, if I said 1/2 and negative 1/2, those are opposites. If I said 5 and negative 5, those are opposites. They're not reciprocals, but they're opposites. Examples of reciprocals would be 1/2 and 2, 2 over 1. Or 2/5 and 5/2. Those are reciprocals. Now, things that are both opposite and reciprocal would be like 2/3 and negative 3/2, in the example. Or negative 7/12. What's the opposite reciprocal of that? Opposite would be positive, and then 12/7. Okay? So those are what we're looking for. We're looking for opposite reciprocal slopes. We don't care about the y-intercept. I'm going to check it. Because they could be the same, they could not be the same. So we're not going to worry about it. Okay, just the slopes is all we got to worry about for perpendicular. So determine whether the given are perpendicular. So I'm going to go kind of fast here. Again, all of these are standard form. I'm just going to get y by itself and then look at it. Okay, bring the 4x over, divided by 2. So y equals 4 minus 2x. So is 2 and negative 2, are they opposite reciprocals? No, not perpendicular. Okay, so this one, they are opposites. One's negative, one's positive. Opposite, but not reciprocal. Okay, opposite, but not reciprocal. This guy here, bring the 5x, would be negative 2y equals 8 minus 5x divided by negative 2. Again, all I'm worried about ability is this guy. This would be a positive because negative 5 divided by negative 2. So it'd be 5 halves, negative 2 fifths. Are they opposites? Yes. Are they reciprocals? Yes. So yes. Opposite and reciprocal. And then this guy here, bring the 6x over, divide by 8. Again, all I'm worried about this number right here. I don't have to really do anything else. If I reduce that, that'd be negative 3/4. So negative 3/4 compared to negative 4/3. Are they opposite reciprocals? They are reciprocals, but they're not opposite. So no. They are reciprocals. But not opposite. Okay? Let's keep going with this bad boy. So, write the equation of the line perpendicular to this. So first off, find the slope of the given line. So here's the given line. The given line has a slope of negative 4. So what's the slope of my line? Opposite, positive. What's reciprocal for? 1/4. Okay. Actually, I'm sorry, perpendicular. I got ahead of myself here. So find the perpendicular, which is 1/4. I should write positive 1/4 over here. And then this is the only change. Everything else is the same. So in parallel, you just write down the same number. If that's negative 4, this is negative 4. If it's perpendicular, then it's opposite reciprocal. Then find the y-intercept. Okay, so this guy here, if this is my given line, I want to find the perpendicular line. The perpendicular line is going to have a slope of 1/4. I don't know what the b is yet. I'm going to plug in 8 and negative 3. So 1/4 of 8 is 2. 2 plus what equals negative 3? We'll subtract 2, so I got negative 5 equals b. So my slope was 1/4. My y-intercept, negative 5. So that's the equation. This is the perpendicular line. Given, perpendicular. Write the equation of the perpendicular line to this guy. Okay. You know, maybe I'll just skip this. Okay, the video is getting long, so I'm gonna skip that. Kind of get the same idea. I think you understand. Now write the equation line perpendicular to the one shown. So first off, the slope of the given. So the slope of the given here is gonna be 1, 2, 3, 4, 5, up 5, right 3. So positive 5/3. That means my slope, so the one I'm finding, the slope, is going to be negative 3/5. Negative 3/5. So y equals negative 3/5 x plus b. Plug in the only point that you know. Okay, this point is negative 5, 6. Plug in negative 5, plug in 6. Okay, so this is reducing. That'd be a positive 3 plus b equals 6. Subtract 3 from both sides. My b is 3. So slope is 3/5, b is 3. Okay, so there's my equation.